Hello, my dear students. I'm Dr. Vaishali Bharambi. I've been teaching anatomy for more than 25 years and I love it. Today, we're going to do something very interesting. We're going to develop the male reproductive system. Okay? So this is part 1 of the lecture. There will be a part 2 in which we will be discussing the descent of testes and the anomalies that are associated with it. So, development of male reproductive system essentially means we have to develop the gonad, which is the testes. We have to develop the two ducts, okay? What develops from mesonephric, what develops from paramesonephric ducts. There is also development of external genitalia. That will be the lecture 3, okay? So at this moment, let me begin by a discussion of the male reproductive system, lecture 1. Right. Just remember one thing before we go ahead. The sex of the child is determined at the time of fertilization. That cannot be changed. But at around the 4th week of intrauterine life, finally, the development of the gonad, which is the testis, begins. So the gender of the child is already determined, but the actual physical evidence of it begins to develop around the 4th week of intrauterine life. Okay? So now let's look at this image. Hopefully you find it familiar. This is the epiblast, this is the hypoblast, and this therefore is the bilaminar embryo. Okay? That's the amniotic cavity, that's the yolk sac, and that's the connecting stalk. Yes, this is quite a familiar image for all of you. Let's cut it at the top. You're looking at the developing embryo from the top. Okay? That's the pear-shaped bilaminar disc. Okay? This light green is the epiblast you're looking at. In this epiblast, in the caudal region, you will begin to see a linear elevation which is called as primitive streak. Now from this, I want to create a gonad. What is the thing that I need to develop testes? I need primordial germ cells. I need the germ cells, right? Where am I going to get them from? Where am I going to get the germ cells from? So now see what happens. From the caudal region of the epiblast, cells begin to go towards the primitive streak, passing through it, emerging out. Okay? They begin to pass to the primitive streak, pass through the primitive streak, and then emerge downwards. These migrating cells form primordial germ cells. And where are they going? See, they're all coming into this region of the developing embryo, near the connecting stalk, near the future umbilical cord. See, these are the primordial germ cells, okay? Now, so this is a section through the developing embryo. Here you are seeing the connecting stalk and allantois, and these are the primordial germ cells, okay? These are the primordial germ cells. Where are you going to find them now? You're going to find them near the hind gut in the splanchnic mesoderm. Basically, this is getting very confusing. Just remember, primordial germ cells have migrated and can be found in the gut region, close to the umbilicus. Enough, okay? Now what happens? Parallelly, around this 4th week of intrauterine life, the body is also attempting to do so much. First thing it does is it creates what is called mesonephros. Now you and I know mesonephric kidney never actually developed into kidney. But the body has to go through the motion. It is producing a number of mesonephric tubules, which are draining laterally into mesonephric duct. Meanwhile, amazingly, your body is very well aware that this kidney is not going to happen. So what does it do? It has started the metanephric kidney development in the lower pelvic region. That's what this image is telling you, okay? But more important than that for us today is medial to this mesonephros, there is development of an elevation called the genital ridge. Okay, genital, yes, related to our reproductive system. Correct. So this genital ridge is developing because of thickening of the lining epithelium of the gut cavity, thickening of the coelomic epithelium, along with some contribution from the underlying mesenchyme. If you can remember this, fine. Otherwise, just call it a genital ridge and move on. So here's the same embryo, okay? Now this is the mesonephros or mesonephric tubules. This is the mesonephric duct which is going to go down and drain into the cloaca. And this is the genital ridge. Now what happens? You know that there were primordial germ cells around the umbilicus region, right? These primordial germ cells now begin to migrate along the hindgut, along the dorsal mesentery to reach the genital ridge. Okay? So, genital ridge, which is the region where the future gonad is going to develop, the primordial germs have reached there and they have started to multiply. Right? So, this is the region where the primordial germ cells have migrated along the dorsal mesentery and are now merrily multiplying there. Okay, step 1 is done, genital ridge is formed, primordial germ cells have reached the genital ridge. Now what happens? Some questions for you to think. Where did the primordial germ cells come from? From the dorsal region of the epiblast. Where did they go? They went to the genital ridge. What are they doing there? They are multiplying there. Okay. Now what happens? Now this is a section through the developing embryo. Okay. This is the genital ridge on both sides. This, at this point, is an indifferent gonad. Do you know what's an indifferent gonad? It has no gender. It can be converted into a male, it can be converted into a female. It gets divided into an outer cortex and an inner medulla. This medulla, in turn, is laterally related to the mesonephric tubules, which are draining into mesonephric ducts. Pause. Think. This is the duct. This is the mesonephric duct. I want you to note. There are two mesonephric ducts developing on both sides. And parallel to that, there is a paramesonephric duct also developing. So what have we got? We've got a genital ridge. We've got two mesonephric ducts. We've got two paramesonephric ducts. Basically, the material that can be used to create the male reproductive system has started to become available to us. Okay? Now what happens? The coelomic epithelium now begins to migrate inwards in the form of cords, which are called as sex cords. Okay, so these are the primitive sex cords. At this point also, so that's the mesonephric tubule and duct. At this point also, the gonad is indifferent. The gonad does not know whether it's going to be a male or it's going to be a female. Then when will it know? When will it know whether it's going to produce a testis or an ovary? It will know because every cell of this embryo, if it has a Y chromosome, it has on the short arm of that Y chromosome, there is something called as an SRY gene. Sex determining region of Y chromosome, SRY. This SRY gene produces a testis determining factor. A factor that's going to be active at this point and therefore result in production of testes. Right? So, this factor causes the primitive sex cords to migrate further deep into the medulla and form what are called medullary cords. What's happening to the cortex? The cortical cords have degenerated. That's the effect of testis determining factor. Under this, now a testis is going to develop. Right. So now you're seeing a section through that developing embryo. These are the medullary cords. Just remember the fundamental. If the Y chromosome, if the SRY gene is there, medulla will develop into testes, cortex will degenerate. Very simple. Opposite will happen in the females. Right. So now what's happening, okay? The medullary cords will form testicular cords. Primordial germ cells are incorporated into the testicular cords. When the boy will achieve puberty, these primordial germ cells will multiply to produce spermatozoa. Distally, these same testicular cords unite to form an anastomotic rated testis. I'll show you an image, you will understand. Just wait it out. So within those testicular cords, okay, you start to develop cells called sustentacular cells of Sertoli. You say it once. Sustentacular cells of Sertoli. What do? These cells prevent further mitosis of primordial germ cells. Primordial germ cells are told you're not to multiply. Why not? You're not to multiply because this is a child. When the child hits puberty under the influence of testosterone, you can multiply, not now. So that is done by cells of Sertoli. They also secrete what is called as a Mullerian regression factor. What is Mullerian? Mullerian duct. Mullerian regression factor, it is suppressing the paramesonephric duct. The paramesonephric ducts are programmed to produce the female reproductive system. So in this case now, the Mullerian ducts are suppressed. Who is doing the job? Cells of Sertoli. They are also promoting differentiation of Leydig cells in the mesenchyme. These Leydig cells will produce testosterone, which will result in further development. Right? So testicular cords were produced, they anastomosed to form rete testes. Within the testicular cords, sustentacular cells were produced. These began to promote development of Leydig cells. So much happening. I hope you're enjoying. Please drink some water or maybe have some coffee, okay? Because things are going to get even more interesting. Right, let's move on. This time an image to keep you going. So here you're seeing the seminiferous, here you're seeing the testicular cords, which in future will form seminiferous tubules after puberty. Meanwhile, the whole thing is surrounded by a lot of mesenchyme. Okay, so this mesenchyme now begins to help out. How? The mesenchymal cells form the inner lining of testes called the tunica albuginea. They begin to give out septa between the seminiferous tubules. They begin to produce interstitial cells of Leydig which will secrete testosterone. And they also produce the mediastinum testes. All this is the job of mesenchymal cells. Okay. So now can you see the testes forming? But what's the use if the rest of the structure is not formed? So let's see what happens now. Okay, the rete testes, which is the anastomosis of testicular cords, they develop a connection with the mesonephric tubules. Remember mesonephric tubules, which were never going to produce the kidney? They are here. Some of them, they form an anastomosis with rete testes to form what are called efferent ductules. These efferent ductules in turn are connected to the mesonephric duct. The mesonephric duct is here, okay? And this mesonephric duct then forms the epididymis and the vas deferens, right? Now can you see the continuity? The seminiferous tubules, rete testes, efferent ductules, mesonephric duct. A whole path has been created for the flow of for the traveling of the spermatozoa, right? And of course, the mesonephric duct is going to open into the prostatic urethra. Okay, so let's use this image to understand. Okay, here you're seeing medullary cords, which are basically going to develop into testicular cords. Okay, you can see they will develop into seminiferous tubules. They will anastomose to form rete testes. Okay, now these are draining into mesonephric tubules, which will develop into efferent ductules. Follow the path in your mind. Mesonephric tubules were draining into mesonephric duct, which is producing the epididymis and vas deferens. Again, watch the continuity. This is how the male reproductive system develops. Let's take it a little further. Whole thing is surrounded by coelomic epithelium, which is between that and this developing male reproductive system. A tunica albuginea is produced and the septa are produced by the mesenchymal cells. Right. Another image to help you understand a little more. This is the developing genital ridge, which is going to develop into testes as seen here. This is the mesonephric duct. These are the mesonephric tubules. Clear? Okay. So now what happens? The mesonephric tubules in the middle will form efferent ductules, right? The proximal and the lower mesonephric tubules, they don't form efferent ductules, but they form remnants, which are called superior aberrant ductules, inferior aberrant ductules, and paradidymis. So these are remnants. Okay, they're not part of the male reproductive system. They are remnants of the mesonephric tubules. This is asked in vivas. You must always remember the remnants. Somehow they interest the examiners a lot. Okay, continuing on the same thing, the very tip of the mesonephric duct can remain behind as appendix of epididymis. Okay, I'll show you an image, you will understand. One more image. Right, these are testicular cord seminiferous tubules. Get that in your brain. This is the rete testis anastomosis. These are the efferent ductules, part of mesonephric tubules. This is the epididymis. This is the vas deferens, developed from mesonephric ducts. This is the seminal vesicle, which is a little bud given off by the mesonephric duct. And finally, the ejaculatory duct. Okay, all this, I think, development should by now be clear to you. Okay, part of it from the efferent ductules is from the mesonephric system. Mesonephric tubules, mesonephric duct. Okay, now what is left out of the mesonephric duct is the appendix of epididymis. But there are two yellow dots here, or orange dots. What are those? Those are appendix of testes and prostatic utricle, which are remnants of that paramesonephric duct which was not allowed to develop in the male. Do you remember Mullerian inhibiting factor? It inhibited the paramesonephric duct, which was forced to disappear, leaving behind these tiny little remnants. Right. So let's revise the remnants once. Appendix of epididymis, remnant of mesonephric duct. Appendix of testes and prostatic utricle, remnant of paramesonephric duct. What about mesonephric tubules? 12 to 15 form efferent ductules. Rest of them from superior and inferior aberrant ductules along with paradidymis. Remnants matter. Right. So with this, we come to the final developmental chart of testes development. Primordial germ cells give rise to spermatogonia. Testicular cords give rise to seminiferous tubules, cells of Sertoli, rete testes. Underlying mesenchyme gives rise to tunica albuginea, septa in between, mediastinum testis, and of course the cells of Leydig. Mesonephric tubules give rise to efferent ductules. Funnily enough, mesonephric duct does a lot. Mesonephric duct gives rise to epididymis, vas deferens, seminal vesicles, part of prostate, and ejaculatory duct. It also contributes to the urinary system. I won't discuss it. I've kept it here. You can always pause the video and read it. Right. So last bit about this development of prostate. Remember, prostate is something that is in between. It is part development endodermal, part development mesodermal. Because the urethra that you have is partly endodermal and partly mesodermal. The mesodermal portion of it gives rise to that part of prostate which is consisting of inner glandular zone. Okay, so this inner glandular zone comes from the mesonephric duct, and this is the part that undergoes benign enlargement of prostate as the male ages. Whereas the peripheral portion, outer glandular portion, develops from the endodermal part. Okay, and this is the part that undergoes cancerous changes in case of enlargement of prostate. So not only do we learn about prostate, we also learn about its pathology depending upon its embryological origin. Okay, so that's the development of prostate in very short. Remember, prostate has a prostatic utricle, a tiny little structure which is also called as the male vagina, which is a remnant of the paramesonephric ducts in male. So that's the male reproductive system, okay, and which we have developed today. I hope you've enjoyed this. What have we learned today? We learned about where primordial germ cells were produced, how they migrated to the genital ridge, how they multiplied or were stopped from multiplying at one point. Then we spoke about the effect of the SRY gene and how it promotes the development of testes and stops the development of Mullerian ducts. Then we have summarized this. I'm not going to read any of this. This summary is specifically kept for you to stop the video and use this table like a table. Just see it, and sometimes you need information stat, use it from here. And if you need to know the description, watch the video again. All right? Okay, students, so what is left? What is left is we need to learn the descent of testes. You have forgotten that you have produced the testes in the dorsal wall of the abdomen. You don't want it there. You want it in the scrotum, which means the testis has to descend down. So that's the lecture number 2. Along with developmental anomalies, are we so blessed that everything is normal? No. There are times when something goes wrong. What goes wrong in the development of this male reproductive system is what we will be learning in Development of Male Reproductive System Part 2, in which we will descend the testes and we will see how much can go wrong. Okay, so I hope to see you across the screen in my next lecture. Meanwhile, remember to watch Part 2. Remember to watch Development of External Genitalia, which will be the lecture 3. Remember to watch hydrocele, the embryology of hydrocele. Okay. And I hope that I'm making a difference in your medical life by giving you information in hopefully simple yet enjoyable manner. Please give me feedback about my lectures. I will be thrilled to understand, and any feedback, I will take it constructively and try and do my best to make your medical journey more fruitful and more knowledgeable. All right? So like and subscribe to the channel, and I'll see you across the screen in my next video. Remember, vbanatomy.com also gives you MCQs, and all this in the form of PDF is available on my website. So you can always go on the website and read up and all this material in the form of notes there. Okay, so do use this material which is being provided to you by a seasoned anatomy teacher and a genuinely heartfelt, dedicated medico. All right, I'll see you across the screen in my next video. Bye.